Hi, this is Divya, Assistant Professor, Biomedical Engineering Department in SNS College of Technology. In this video, we are going to see about photomultiplier tube. What is photomultiplier tube and where it is present? Okay, photomultiplier tube is present in a gamma camera, and we'll see why it is used. Okay, photomultiplier tube is present very next to the collimator. Okay. Collimator will have a lead disc, and lead disc contains a crystal where will have many holes in it where the radiations will be passing through. Okay, next to that we'll be having a photomultiplier tube. Okay, the radiations which is passed through the collimator holes is that radiations will be combined together and it will be passed through the photomultiplier tubes. Okay, 30 to 100 photomultiplier tubes sit behind the scintillation crystal. As I told you already, collimator next to the lead crystal will be having a photomultiplier tube. That photomultiplier tube contains 30 to 100. For a single gamma camera will be having a 30 to 100 photomultiplier tubes. The purpose of these is to multiply the small amount of light detected from the crystal to larger signal. Okay, the purpose of the photomultiplier tube, the main purpose of the photomultiplier tube is to multiply the amount of light detected from the crystal to the large signals. Okay, the light photons hit a photocathode at an entrance of the photomultiplier tube. We can imagine that. Okay, I'll show you in the diagram. See, in this diagram we can see that the tube will contain the anodes, cathodes, denodes. This red one is called as dinodes. And finally we'll be having the anode. This blue one is called as anode, and this left side blue one is called an photocathode. From the photocathode, rays will be hitting into the first dinodes, and from the first dynode it will multiply. This is photomultiplier tube, right? So one signal will be multiplied into 2 or 3. Okay, that multiplied signal will be passed into the next dynode, and from that dynode again the dynodes will be multiplied and will be moved on to the next dynode, and that will multiply the signal and again it will be passed on to the next one. Likewise, each dynodes will multiply the signals and finally it will be transferred into the anode, where it will be converted into an electrical signal. Okay, as I told you, the photocathode releases electrons in the proportion of the amount of light that hits it. The electrons are attached to the electrodynodes, which have an increasing positive charge along the photomultiplier tubes. This accelerates the electrons. As they accelerated, they gain kinetic energy, resulting in multiple electrodes. As I told you already, right? One signal will be multiplied into 2, another will be multiplied 4, 8, 12, likewise. So as they accelerate, they gain kinetic energy. Kinetic energy is the movement of energy which we get, results in multiplying electrons being released from the dynodes from each electron, and that hits it. This serves to multiply the original signal. Okay, the total electrons hit the final anode, and the current produced from the signal received by the pre-amplifier. As I told you already, the final after all the multiplication process, finally it hits the anode. That anode will convert the complete energy into a electrical signal. Okay, that signal will be passed on to the pre-amplifier part, which is next to that. Okay. pre-amplifier, which is okay, after the amplifier anode, outside of the outside of the photomultiplier tube will be having a pre-amplifier stage, where this signal, converted electrical signal, will be amplified to reduce the noise in it. Okay. Next we will have the XY positioning circuit. What is XY positioning circuit? A gamma camera also can be used for dynamic imaging studies, in which changes in the radionuclide distribution can be observed as rapidly as several images per second. This allows psychological information to be obtained so as the rate of tracer uptaken or clearance from an organ of interest. Okay. Generally, this XY positioning circuit is that since we are going to identify the images or identify what is present in the body by using the images. That images, the scanning images, will have to be in a position of X and Y X and Y axis. If it is in the X and Y axis, we will be able to identify the image clearly without any disturbances. If not, if we have any 3 axis, it will be difficult. In the 3 dimension, it will be bit difficult to identify what kind of image is that. So we are going for XY positioning circuit, which is generally used to position the image which is scanned or which is being processed. Okay, thank you.